This chapter is about balancing chemical equations. Okay, so let's start with something that's unbalanced and we'll see why we should balance them. So you have Mg plus O2 producing MgO. Okay, now the way to figure out if something is balanced or not is to count the total number of atoms on the left hand side and the total number of atoms on the right hand side. They have to be the same. Now the question is, why should they be the same? You will remember something called the law of conservation of mass. The law of conservation of mass says that mass cannot be created or destroyed. It can just change from one form to another. That means that you cannot create mass out of thin air, nor can you just let it go without it becoming a different form. So what's that got to do with chemical equations and chemical reactions? If on the left hand side you have more atoms than on the right hand side, that means you're not accounting for the mass. The remaining mass that is not there on the right hand side has just disappeared. Or if you have lesser number of atoms on the left hand side as compared to the right hand side, then what are you saying? You have created new atoms out of nowhere. These two violate the law of conservation of mass. So in order to satisfy the law of conservation of mass, the total number of atoms on the left hand side have to match the total number of atoms on the right hand side. Now let's count and see how many atoms we have in this equation on the left and on the right hand side. Okay, so magnesium here has one atom. Oxygen 2 has 2 atoms. So totally there are 3 atoms on the left hand side. Magnesium oxide has 1 magnesium and 1 oxygen. So it has 1 plus 1 having only 2 atoms. What does this mean? There are more atoms on the left hand side as compared to the right hand side. What does this mean for the law of conservation of mass? We are losing an atom. You can't just lose something. It has to take another form. So it is our duty now to balance this equation. This equation right now is what is called an unbalanced equation. So now the question is, how do we go ahead to balance it? Before we look at how to balance something, let us watch what this actually means to balance it. Let's assume that this blue magnet is your magnesium atom. Let's assume again, these two yellows are your oxygen atoms. So what we are saying is, this Mg plus O2 is reacting to produce MgO. So this Mg and this O have gone here to create MgO. The problem now is, what's happening to this guy? This oxygen atom cannot just disappear because we have just spoken about the law of conservation of mass. Mass cannot be created nor destroyed. Here, it looks like this mass is being destroyed because this has no place to go here, right? In order for this guy, this oxygen, to go to the right hand side, what is necessary? Another blue is necessary. So we have to introduce another blue. Okay? By introducing another blue, what have we done? Let's rewind this and see. These two oxygens can go back here as O2. Magnesium, so this is a molecule, an oxygen molecule. This magnesium goes back to where it came from, and now we are adding another magnesium. Okay, so remember, look at this. These two magnesiums are not joining together. They don't have a bond. These oxygens have a bond. Okay, the oxygen bond is there, but these are separate. So we have 2 magnesiums here and we have a single oxygen molecule here. You write it at the bottom, the number 2 comes at the bottom if the 2 atoms are connected. The 2 comes on the side if they are not connected. Okay, these are 2 independent magnesium atoms. This is an oxygen molecule. Okay, so that's why the 2 is at the bottom here. Now what have we done? Because we have introduced a new blue here, these two have formed an MgO and these two have formed an MgO. So what does this mean? This means that we are rewriting the equation to be 2Mg plus O2 produces, this is an MgO, that's an MgO, so 2MgO. Okay, so this equation is now balanced because the total number of, there are no atoms left on the left hand side, everything has now found a space on the right hand side. Okay, so 2Mg plus a single O2 molecule can create 2 MgO compounds. So this is now what we call a balanced equation. Okay, this is the simplest way for you to visually understand why something has to be balanced. The next example is zinc plus sulfuric acid creates zinc sulfate plus hydrogen. So that's the word equation. Now let's write the chemical equation. It may or may not be balanced. We won't know until we've actually written it. So let's write it. Okay. What is zinc? Zinc is Zn. Okay. Then this combines with H2 SO4 and this creates Zn SO4 plus H2. Okay, so that's the equation for this particular word equation. Zinc combines with sulfuric acid. Zinc's formula is Zn. Sulfuric acid is H2SO4 to create zinc sulfate ZnSO4 plus hydrogen molecule. Now the question is this balanced or not? Now let's visually do this once and then we'll go and see how we could do it in a more quicker way. So let's do it visually so that we understand what we are doing. We have zinc. Okay, now zinc is combining with H2SO4. Okay, so zinc is combining with H2. The yellow ones are hydrogen, the red one is sulfur and the blue ones are oxygen. And we are saying it is creating zinc sulfate plus hydrogen, right? And we have the equation here. When do we say that something is balanced? We say that an equation is balanced if there is total number of atoms on the left hand side match the total number of atoms on the right hand side. For that to happen, if I start moving this to the right hand side, to create these two equations, I should not need any more atoms, nor should any atoms be left on the left hand side. Okay, let's do it. I need to create zinc sulfate, I need a single zinc. So I will take this zinc and put it here. Okay, I need one sulfur. So I'll take this sulfur and put it here. I need 4 oxygens. So I'm going to take these 4 oxygens and put it on the right hand side. Okay, so zinc sulfate is created. What do I need? I need to create my H2 now. So to create this H2, I'm going to take these 2 hydrogens and move them here. Okay, so now my formula matches. I took every single atom that's there on the left hand side and I was able to create the atoms on the right hand side without needing any more atoms, which means that my equation that I started with was already balanced. There's nothing for us to do. If you count the total number of atoms on the left hand side, here zinc has 1, hydrogen has 2, sulfur is 1 and oxygen is 4, 4, 5, 6, 7. So there are 8 atoms on the left hand side. On the right hand side you have zinc, which is 1, sulfur is 1, oxygen is 4, hydrogen is 2. 4, 5, 6, 7, 8. There are 8 atoms on the right hand side. If the total number of atoms, 8 on the left hand side, matches the total number of atoms, which is 8 here on the right hand side, the equation is a balanced equation. There's nothing for us to do. Alright, now what we can do is let's take a look at another equation and see if it is balanced or not. And if it's not balanced, we'll go ahead and balance it. Okay, iron combines with water to produce iron oxide and hydrogen. Okay, that's your word equation. What is the now let's write the chemical equation for this. What is iron? Iron is Fe. The reason iron is Fe is because the Latin name for iron is ferrum, and we took the first two letters of it and called it Fe. Water, no points for guessing what water is. Water is H2O. Okay. Now this reacts to create iron oxide. The formula for iron oxide is Fe3O4, and then you also have a single hydrogen molecule left from this. Okay, now we need to know whether to balance this or not. Okay, first let's do it visually and see what's actually happening, and we'll then find a way. You can't do this magnets thing in your exam, right? So we'll also find a way to do it without all these magnets. But let's do it visually to understand what it is that we are doing. Okay, let's take iron. I'm going to give iron this yellow color magnet. Water has 2 hydrogens and 1 oxygen. So that's water. It produces Fe3O4. Now, I have a problem. For law of conservation of mass, everything on the right hand side should come from whatever is there on the left hand side. On the right hand side, he is asking me for Fe3. 3 Fe's are required. Where do I get these 3 Fe's from? I only have 1. So, in order for me to be able to have 3 Fe's, I need to have 3 Fe's on the left hand side. Clear? Now this is not Fe3. Remember that this is not Fe3 because this is not an Fe3 molecule. These are 3 independent iron atoms. Look, they are not. Look at H2O. They combine. They are touching each other. This is not touching because they are not a molecule. Okay, so you have 3 Fe now. Okay, so I have 3 Fe's. Now these 3 Fe's can go and form Fe3 on the right hand side. Now they are touching because it's an Fe3 molecule. Now what do I need? I need 4 oxygens, correct? Where do I get 4 oxygens from? I only have 1 oxygen on the left hand side. So in order for me to be able to have 4 oxygens, I need 4 water molecules. So let's do that now. So here is the second water molecule. Okay, ignore the shapes, just look at the colors. Okay, so this is another water molecule and this is another water molecule. So in order for me to have 4 oxygens, now I have 4 oxygens, 1, 2, 3 and 4. So these 4 oxygen, to get those 4 oxygens, I've had to bring in 4 water molecules. Okay, so I have 4 H2O. All right. So now these 4 oxygens come from these 4. So I'm going to take this and put them here. So Fe3O4 is now satisfied by this 3 Fe and this 4 H2O. All right, good. So now what happens to all these hydrogens that are left here? On the right hand side, I'm needing 2 hydrogens. So those 2 can come from here. But remember, what does law of conservation of mass say? You cannot just let atoms disappear. These things on the left hand side need to have a place on the right hand side. So what do? We are going to take these. So we already have 1 hydrogen molecule. I'm going to take the second hydrogen molecule and put it on the right hand side. I'm going to take this third hydrogen molecule and put it on the right hand side, and this fourth hydrogen molecule and put it on the right hand side. So I have 4 hydrogen molecules on the right hand side. So that means my equation now becomes Fe3O4 plus 4H2. Now you can see that every single atom that was on the left hand side has now found a place on the right hand side. So this equation is now a balanced chemical equation. And you visually saw why we had to do it. Now let's find another way to get the same answer so that you can do it in your exams easier. Okay, so now you're in your exam, you've been given this formula. How do you actually figure out how to balance it in an exam? The simplest way to do this would be to draw a table. Okay, on the table, list down every single element that is there in your equation. So you have iron, you have hydrogen, and then you also have oxygen. Now what you do, this is your LHS and this is your RHS. Okay, how many ions do you have on your LHS? You have 1. How many hydrogens do you have? You have 2 hydrogens on your left hand side. And how many oxygens? You have 1 oxygen on your left hand side. On your right hand side, you have 3 ions, you have 4 oxygens, and you have 2 hydrogens. Okay, so you write this table first, and then you find out where is the largest number. The largest number is over here. It's on oxygen on the right hand side. Okay, so for us to be able to get 4 oxygens here, I need 4 oxygens here, correct? Which means I need to multiply whatever is generating my oxygen, wherever my oxygen came from, that needs to be multiplied by 4 for me to be able to get 4 oxygens. Where did my oxygen come from? My oxygen came from H2O. So I'm going to multiply that by 4. Okay? So now when I multiplied this by 4, what happened to my hydrogen on my left hand side? So once I multiply this by 4, I have now 4 oxygens. Okay, so that is fine. This is matching. What happened to my hydrogen? My hydrogen is now 8 because I multiplied it by 4. So 4 2s are 8. So now I have 8 hydrogens on my left hand side. But on my right hand side, I only have 2 hydrogens. What do I need to multiply 2 by to get 8? I need to multiply by 4. So I need to multiply wherever this hydrogen is by 4. So this H2 gets multiplied by 4. So now I also have 8 hydrogens on my right hand side. This is also matching. Now I have 3 iron on my right hand side, but I only have 1 iron on my left hand side. What do I need to multiply 1 to get 3? I need to multiply it by 3. So wherever my iron is on my left hand side gets multiplied by 3. So our new formula, which is now a balanced formula, is 3Fe plus 4H2O gives Fe3O4 plus 4H2. This is the same formula that we visually saw with the magnets, and now we've also mathematically done it using this table. Hope you've understood how to balance an unbalanced chemical equation. If you have any questions, write it out in the comments and I will help you understand it better.